Okay, so those of you may have joined us a little bit late. There is one change to the schedule. So our 2 p.m. talk and our 10:45 talk actually swapped. So those of you who might have come in after lunch looking to hopefully hear Rory McCune talking about your framework has failed you, have unfortunately missed it. He's already been and gone. But we've been saving that which you guys will love, because he is a force of nature. Dennis Cruz, who's going to be doing our 2 p.m. talk on OWASP O2 platform, app sensor integration, and stuff like that as well. I know we have a bunch of folks who are probably coming in and out during the day, so that's the only change to the program is the 10:45 and 2 p.m. Talks have swapped. Also, a quick other admin note. As I mentioned before, and I mentioned via the Eventbrite RSVP kind of sign-up stuff, I will put out one last mailing before I basically delete the event, which will come out to you via Eventbrite, and that should have details of how to join the OWASP London mailing list, and also various other bits and pieces of information about OWASP, and also stuff from any particular links that the speakers wanted to make sure that everyone had. So if there's anything you want to add to that, just drop a line to me, speakers. If there's anything you want to point people to, like the Survey Monkey, the CISO form, I'll make sure that all goes out to you there. That is the last time you will hear from me via that way. So if you ever want to hear anything more about OWASP London, make sure you join the mailing list, as I mentioned. So, excellent. And apologies for the Gotham branding. I did try and remove it, but it didn't really work. What I'm going to talk about today, my name is Justin Clarke, those of you who haven't met me already, is talk about something that you may well already be using. So, who here knows about PMD? 4 of you. Okay. Of the 4 of you, who's actually using PMD as part of your development process? 3 of you. Okay, that's it. That's awesome, actually. So we've got 75% uptake of those of you who actually even know what PMD even is. Okay. The focus of this talk is leveraging stuff that you may already have integrated into your development toolset. You know, PMD is the one that we're going to be talking about at the top, PMD, Messenger, but we are talking about the kinds of things which are part of your development stack, your lifecycle process, you know, things like, you know, you might be using Ant, Hudson, Hudson's a bit old school. You might be using, you know, some of these kind of tools within your framework, and how can we utilize stuff that you're already using, or may already be using, for security kind of aims? Which is why it's called kind of teaching an old dog new tricks, because PMD is not a security tool per se. So what we're going to do is we're going to talk about what is PMD, understand a bit about how it works. Then we're going to turn around and extend it. We're going to extend it to do stuff that PMD is never intended to do, and to some extent does or does not do well to actually get something useful out of it from a point of view of security. And you know, this is not something which is limited to PMD. These are the kinds of things that you can do yourself. Reason for this, and one of the key kind of things is this is a very gentle introduction to the concept of static analysis. If you haven't really thought about that from a security point of view as of yet. So static analysis, there's a lot of tools out there which are more on the quality side of things. So you guys might be aware of things like find bugs, you might be aware of PMD, you might be aware of things like FXCOP. All of these things are basically quality assurance, static analysis things. And this is really a very gentle kind of introduction which is going to get you into doing some source code analysis. This is probably not the end point for most of you if you actually get into this seriously, but it's certainly something which kind of gets you down that path. Like it is not if you're actually seriously looking at it, you'll probably end up going commercial. One of the tool sets which are out there, HP, Veracode, IBM, Coverity, there's a lot of them out there. So, what is PMD? Open source static analysis tool, quality focused. It's Java only in the version that we're looking at. So we're looking at, in this particular case, PMD version 4. PMD version 5 does support more languages, but the particular one that we're looking at extending is the version which has been stable forever. It's been stable for 7 or 8 years. Version 4. Version 5 has come out relatively recently, but it's not quite there yet. Kinds of things it's looking for: dead code, suboptimal code, overloaded or overcomplicated things, duplicate code. So it's all more kind of quality focused. Very little related to security. Very little really. Kinds of things we might be looking at, like possible bugs might be, for example, empty exception handling. So maybe you catch an exception, but you don't do anything with it. So you have an empty catch block. You might also have unused variables, parameters, and you might have private methods which never get called. That's the kinds of things that PMD is quite good at picking up. So from the point of view of finding bugs and things like that, we already have, if we're using something like PMD in our development lifecycle, we already have something in there which is going to help us find bugs. Buggy patterns, so the example I gave you there with, we catch an exception, but then we don't actually do anything with it. Maybe we have a policy that, we at least need to log exceptions, or maybe you do need to debug log it. Maybe you just forgot to actually put there. So these are kind of patterns that we can identify, which are really just for finding bugs. PMD, excellent, things like that. They are usually very good at keeping the noise down. So they do there is always static analysis, a certain number of false positives, but generally things like this, and if you use things like find bugs, if you use things like fxcop, all of these kinds of things are usually fairly accurate. Unfortunately, when we extend this to security, it actually gets a little bit, it's a harder problem. It's a way harder problem. And we're really in that particular case, as opposed to looking like a concrete structural thing that we can identify. So the example of an empty catch block, we can see that we are handling an exception, and then we can see that there's no evaluatable code which is actually going to be executed if there is an exception. That's very easy to reliably write rules for. It's very easy to identify. When we're talking about things on the security side of things, though, it becomes much harder. So cross-site scripting, for example, I'm accepting input from a user. So first of all, I actually have to have a good understanding of stuff which comes from a user. And then I'm rendering it out to the user, potentially somewhere completely different within the code. So this is actually a significantly harder problem to solve that is inherently a little bit more prone to false positives and also prone to false negatives, especially with a tool like PMD. So we're going to talk about some of the, and context is important in this particular case. So cross-site scripting, for example, the pattern is we're accepting input from a user and then rendering it back to the user. However, in what context are we doing it? Is there input validation controls? Is there output encoding controls, which would actually render that to actually not be an issue? All of these things are important and things like that. Some of which we can to some extent mitigate with PMD, and some of which we can't. So you kind of get what you can with this thing. I'll go through some of the limitations of the approaches that we've taken and things like that. Why PMD? Largely because PMD is, in the Java side of the house, is probably the most commonly installed toolset for this kind of analysis. There's really two things that you'll come across all the time on this, PMD and find bugs. And of those, PMD is a lot more flexible if you want to actually write your own things. So it's extremely common, especially in enterprise environments, that you might find PMD already integrated. So as I mentioned when we started, what we're looking to do is we're looking to take something you're already using, you already have it running in your development builds, You already have it probably being included within your continuous integration reports. So you already have the kind of the plumbing, the framework kind of stuff in there. It's highly customizable, so we can really do a lot of stuff around kind of how we present things. So we can extend the rules and reporting, so we can add stuff in there. We can do security stuff specifically in there, and it's very used. Use it in Eclipse, for example. We can use it in tools like Hudson. Very easy to do it. And it actually is a full-blown static analysis solution with some caveats. So, and it's been around since 2002 as well. So it has a lot of history behind it. So how does it work? Who here actually uses a commercial static analysis solution? So Fortify or Ounce or something like that. Yeah, okay, so there's a few of you here. Those of you who are familiar with these things, this will sound to some extent quite familiar, because this is very much how a compiler works. So we're running it against source code. So we usually, commonly the common situation is running against source code. What it builds is it builds an abstract syntax tree. Anyone remember that from compiler theory, computer science classes, abstract syntax trees? Yeah. So what this is it basically it's an intermediate kind of representation of what that code is syntactically. And that's really used by compilers for building things and things like that. It then runs a set of rules, some of which ship with the product, some of which we've added, to do certain types of analysis. So it's the abstract syntax tree is what we're actually parsing rules against, and then we report stuff coming out. So it's a relatively kind of straightforward process if you look at it. If you actually dive into the implementation and the how it's actually done, it gets very hairy very quickly. But at the high level, it's kind of quite easy. So source code wise, we might have something like this. This is an example class. Doesn't really do anything. We declare a method. Method has a loop. So abstract syntax tree, we end up with something like this. So we have a compilation unit, we have a type declaration. That type of declaration is a class declaration. It's an unmodified class declaration because we're not inheriting anything. Blah, 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 blah. So all of the various bits which are syntactically part of this, including things like the names of methods, the names of parameters, all of this kind of stuff is there, represented in something which is very tree and parsable. So those of you who work a lot with things like maybe XPath, for example, you can see that this would be quite easily searchable as nodes. In fact, that's kind of one of the ways that we're going to look at doing this. So, how do you do custom rules? There's two different types of them. First one is XPath expressions. So we're literally searching for things which are within the syntax trees. The other one is Java classes, which is, there is some limitations on what you can and can't do with both. You wire up the rules, modify any properties about how you want things to work, group them into rule sets for enforcement, and run them. So, key difference from the point of view of what we're looking at here is there is some limitations on kind of what you can and can't do. XPath is very much looking for code patterns. So if we're looking, and this goes back to the example that I had there of the empty catch block. So in XPath expression, it's very easy to find, to pass through and sit there and go like, tell me every time I have a exception caught, but I do not actually have any code within that block. That's something which is very easy to kind of parse out with XPath. If we're looking at anything where perhaps something happens at one piece of code and we want to be able to trigger it based on another piece of code, we're actually looking at Java classes, and we actually need to do it significantly more heavyweight at that point as well. The reason I mention this is because if you're looking at doing this kind of stuff in Eclipse, for example, it's very easy to get it working with XPath rule sets, and extremely hairy and difficult to do it with Java. So in this particular case, PMD, if you really want to do something totally custom, you really can't do it easily in Eclipse, for example. you really have to be doing on the command line as part of your build process. So that's a little gotcha. So in the interest of showing you just how horribly disgusting and complex this is, I'm going to have a demo. This is actually not too scary because there's a lot of resources which tell you how to do this, but I'll give you a feel for kind of what it's like with the rule writing demo. And I'll give you a caveat at this moment. This is all going to be live, so it's not 100% guaranteed this is all going to work. It all worked yesterday when I went through and made sure that everything works, but let's see how we go. So, first of all, we have our piece of code. And what we're doing in this particular case is we've got a servlet. So this is an HTTP servlet, and we have some custom functionality. So the example that we've got here is you have some custom functionality that you use for authorization. And here it is here. I might make it a bit bigger just so people can see it. Just a bit bigger. Okay, well, effectively what it has there is we have a utility class called authenticator, and then we have basically a boolean is authorized. You know, is this user authorized? So basically we have basically some logic which says if the user is not authorized, throw an error. So it's this fairly simple kind of logic, but this is custom logic. So the thought in this particular case is we're going to implement this functionality, and we would like to write a rule to find out where that's not actually done properly. So if we have some examples, you can see the doGet method, which is this one here, we don't call it at all. And also, the doPut, we don't use the same pattern. So we have three different examples of this, which are there. So what we would like to do is we'd like to write a quick rule which basically says, find me all the times where I'm not actually implementing that particular check, how we're supposed to. So we're going to look basically for some errors. So I'm going to get out the PMD rule designer. And basically what this is effectively it's a fairly rough but like very useful tool set for basically just trying out XPath queries against sample code, just to actually test out these rules before you implement them. So it allows us to do some very simple kind of like testing of these things for development purposes. And as you can see on the left-hand side, I've actually pasted in the same code. So this is the code that we just saw in Eclipse in here. So because I'm going to cheat and just copy and paste everything in there as opposed to doing it from scratch, and you'll see why, we can do things like this. So for example, start at the beginning. Let's identify all method declarations. So go, and we have 3 different method declarations. So this is just an example of showing it. We have a declaration of a method here, we have another one here, and we have another one in the middle. Okay, so that's a nice easy one. How about method declarations where we call that particular method? So believe me, if you're actually familiar with XPath, this makes everything a lot easier. But unfortunately, they are a tendency to be quite long. So what we have here is we have basically find me method declarations which contain block statements. So effectively we have a statement called authenticator.is authorized. Okay, so we test that. So we're effectively just iterating through and just building this as we go. So if you remember, we had 2 different instances where we actually had this, and then we had one which didn't. Okay, so we've managed to figure out how we would actually reference there being the presence of that. Okay, so let's add a little bit more logic. So instead of just is it present, how about we look for situations where it's in an if statement. So we want to make sure that there actually is an if statement wrapping it. So effectively this is the same as the previous one, except that we actually also have an additional one of an if statement. Okay, so we only have one of those. So we have one situation where we've wrapped the is authorized kind of check in there. Okay, so really what we've got at the moment is we've kind of got the opposite of what we want. What we're really interested in is we're really interested in all the situations where we don't have this. So effectively, kind of what we really want is, we really want to just not that, which is relatively straightforward. So here we are basically doing the same thing, but we've wrapped the entire thing in a not. So where do we have a method declaration where we don't have a call to our is authorized thing in an if statement? And we have two of those. We have two of those, one of which is, handily, just make this a bit bigger. One of those is the one where we don't have a call to it at all. And the other one is the one where we have it in the put, but it's not within an if statement. So this is the kind of logic which is relatively straightforward to implement. The syntax is a bit gnarly, but basically once you've got a few of these, and there's of course examples with the code that I'll point you to, which is out there on GitHub that we released some time ago, which kind of gets you started on this kind of thing. So it's very easy to implement these kinds of checks and very straightforward. So what we'll do is just going to throw this into a demo rule set. Going to throw together a script, and we're going to run PMD. Things I'll point out. We've got a few bits and pieces. A lot of this is just path stuff to me. Got a few things in there. The PMD GDS toolset is not strictly necessary for this particular bit, but it is for the next one. The second one is the source path to where we're going to run it to. And basically we just need to make sure that the PMD, the various things are on the class path, and we pass the various bits and pieces to it. I'll show you the rule set that we're using. Let me just open it up. The rule set we're using is just very, very simple. So here it is, core authorization, missing call to is authorized, and then we basically have our rule. So, unfortunately, it's one thing I'm doing wrong. Sorry, I've got things all over the place. Actually, at this point, let me just shortcut one particular thing. Can anyone tell me what's wrong with this particular example if we run it across our entire Java source code? If we run this across an entire Java web, what are we going to get?
You're going to get errors on all the other source files that don't care about this rule.
Exactly. So what we really want to do is we really want to do one more thing. And that one more thing is basically we want to constrain this to certain types of classes. Now, this particular one is basically a servlet authentication authorization kind of rule. So what we'll do is we'll basically just extend the same thing. And what we're doing in this particular case is we're only looking for things which are either implementations of servlet or extend servlet. So we're going to constrain these to kind of just a subset of things. And we'll run this. And this is the bit where we find out whether it all works or not. So here we have, this is the original one without that particular fix. And then let me just change the rule set. So many windows open at the moment. Let me just deal with it home. So here's the one that we were just using. So what I'll do is I will just comment out uncomment the one who's just looking for the classes. So now, instead of, so you can see we've got a few ones there, demo, class, SQL injection, authenticator, Java, those things are not servlets. Run it again with the new tool set, and then I've
left out there includes
where did I do it?
these close, the comment close should be lower.
Oh, yeah, you're right, yeah. Badly formed XML. Fail, Justin. And then we get just the things we're looking for. So very, very simple kind of example, very easy. So we're looking at kind of like a more complex example. That kind of example is very easy to do with PMD just out of the box. If we're looking for, and there's a lot of resources which help you do this, a lot of books, a lot of information on the actual PMD website itself. So if we're getting into things which are more complex, we need to actually extend the functionality of PMD itself. Fortunately, I think it's right at the end. We've actually released this tool set. It's on GitHub, it's open source, freely available for everyone to use. I think it's just github.com/GDS security. So what we were trying to achieve for this first set of iterations of functionality was really just to get some kind of basic security rule sets out there for Java. Just to kind of get some basic kind of stuff in there. Also, we'll talk about some of the things where we had to do some workarounds to actually get things working at all. And what we've done in that particular case is we don't want to actually modify PMD itself. So we don't want to actually have to actually run a custom GDS version of PMD. So we want to basically give you something that you can basically have on the class path and that you can extend and use. And we're also looking for just like the basic stuff. So we're looking for OWASP top 10 issues. And in this particular case, we're really only looking for 4 of them. So we've basically got, it's not even OWASP top 4 actually, it's really kind of OWASP top 4 of 10. But it's certainly a start, and we want to do stuff which is way more complex than the lexical pattern matching. So the XPath situation there, that's very much lexical path matching. So we wanted to kind of get a bit more further past that. So selecting the kinds of things that we wanted to do. So we found these things, for example, a customer may have a secure coding guideline, or you may be implementing a particular standard there. And the intention really was to kind of design rules which would kind of give you a basic kind of stuff there. So, and those map to OWASP top 10, such and such. So these are the kinds of things that we're looking to implement things for. However, and this is where it becomes the caveat of extending something which is really not intended for what you're using it for. PMD has a number of limitations which you need to be aware of. And this goes very much towards the false negatives. First of all, analysis is limited to a single file at a time. So if you have a vulnerability which involves basically something happening in one file or one class, and then the issue itself being exhibited in another class, say for example a class that it calls, we can't do anything about that. We're not going to be able to pick up that particular situation. So complex situations, especially kind of second order or stored situations where some piece of data is taken at one point and then it's rendered somewhere else, PMD is not going to be able to help you with that. However, there is a certain number of situations where, and we'll talk into some of the things we've kind of done workarounds, where this does actually certainly give us some very useful stuff. The data flow analyzer is limited to single methods. So even within a class, it's very much limited to bits of that class. It has some limitations on how it tracks variables. Symbols are limited to the source file, so we can't really be using external symbols. Since we can't actually trace them into external things anyway, that's not a huge limitation, but it's something to be aware of. And we can only analyze HTML compliant JSP files. Does anyone here actually write XHTML compliant JSP files? My God, I'm impressed. However, we can get past a lot of these things as well. So we'll talk about the kind of the jumps we've taken there, and also some of the approaches to kind of overcoming some of these limitations. Problem number one. Nobody writes XHTML compliant JSP applications, with the exception of one person at the back. If you've ever tried to do this, it is quite painful. So basically what we do in this particular case is, instead of actually directly looking at the JSP files themselves, we take an approach that many of the commercial tools do as well, and we actually compile the JSP. If you haven't done this before, basically what happens is you compile the JSP and you end up with Java. So we compile it all together, and then we can actually analyze it just like Java. You end up with a JSP service method. So this makes things considerably easier for our analysis. It also means that we are basically able to analyze anything which is in JSP files, and because it's all within one method, we're effectively enables us to analyze the entire JSP page as well. So example, scriptlet code, we get a parameter, and then we write it out. So it's a very simplistic cross-site scripting example, and we end up with something like this as the Java code, which is equivalent. So we've snipped a lot of stuff out there. It's quite noisy, it's generated code, but you can see the kind of the basics of what's going on. Out.print instead of a directory. Problem number two. So writing reports, rule writing changes. So how do we actually get the information out of JSP? So we just compiled the JSP into Java. So that's great, except that we just found a problem in the Java JSP code. How do we actually render that back out, not pointing to line 117 of the Java, but actually pointing to line 20 of the JSP? Fortunately, of course, Java has its own particular ways of doing this. We need to be using SMAP, which gives us basically I hesitate to call them debug signals because they're totally not, but that's effectively what it is. It's basically the mapping between the actual JSP and Java code that's going to enable us to actually then render out to the original JSP code. So we end up with something like this. It's basically kind of an index which we can use to find the references to where we were in the Java JSP code itself. So, problem number three. Despite its very, very big limitations on data flow analysis, we need to kind of do what we can. So we want to be able to do some tracing of information from just common security source code analysis from a source of tainted data to a sink, which is a dangerous function or a potentially dangerous functionality. So effectively what we had to do is using the PMD DFA symbol table, and we also do some kind of custom wiring as well of these things to kind of get it as good as we can within the constraints of PMD. So the kinds of things I'm talking about, we have where data comes in, and we have where data is assigned. So basically the flow of data through the program. Variable definition, variable reference is an input to the code. We have a tainted source, it's a get parameter. We know that comes from a potentially untrusted user. We are then doing a reference, we're doing an assignment. So it's going to end up in B1, and then what we're doing is we're doing a dangerous, potentially dangerous functionality with that kind of thing. So cross-site scripting vulnerability. So we are doing a certain amount of this within the constraints of what we need. It does have the constraints of the fact that it is one class or one page. So it's very, very good at doing reflected cross-site scripting. So we're taking information in a page and then rendering through it out. PMD actually works quite well for that situation. Anything else? We have some limitations. So we at least get some basic functionality here with some wiring in our tool set, basically for free. So very useful. I'll show you an example of running this later. Equally, SQL injection. So remember, we talked about a situation where we take in information and then we actually basically render it out to a function. SQL injection, we couldn't actually normally write rules to find it the same way that, say for example, a fortify would. Because we can't actually trace it from one part of the program to another part of the program. What we can do though, is we can pick up what amounts to dangerous coding patterns. So we can find things like string concatenation. We can find things like calling into things which are SQL commands with concatenated strings. So it's a little bit noisier, a little bit more prone to false positives, but we can still get some useful things there. And I'll very quickly I'll just run it just to show you guys what it looks like. Second script, let's give you an example of the kinds of things that we can do. And we're using the PMD reporting functionality in this particular case, so we can get something which, believe me, isn't very attractive, but it's certainly something which is usable. So we'll just start up the browser and show you what I'm looking at here. So we have some things like this. So we picked up a few general kind of cross-site scripting issues. We found something which appears to be basically building a concatenated kind of SQL string. We also have a few bits and pieces which are kind of more generic bits and pieces there as well, and an unvalidated redirect. So we have, effectively we have coverage of some coverage of 4 of the OWASP top 10. So this is kind of what you can do with a little bit of kind of basic customization and wiring of PMD.
So it's a good, Justin, how do you deal with false positives?
You get them, lots of them. And unfortunately, unlike using a commercial tool set, there's really no way to remove them. So you would actually just have to learn to ignore them. Or perhaps you wouldn't be using these rule sets in every build, for example. You might run them on a periodic basis. But unfortunately, because of the limitations, we are a little bit more kind of false positive. Remember what I talked about with regards to security stuff? We're not necessarily looking at structural patterns of code. We're looking at usages, and therefore we're a little bit more prone to both false positives and also missing things as well. We've gone a little bit more towards making sure stuff's in there, even if it's a false positive. Then, so it's going to be potentially a little bit noisy. How would you go about using them? Basically, you just need to add our customization extension stuff to the class path, and then basically use the rule set. It's literally that easy. And all of this stuff is all available on the GitHub, which we have a reference at the end. And this is basically just like you would do with any of your other PMD rules. Example of integrating into your ANT build, very straightforward. If you have an ANT build, equally, it's no more challenging to do it using Maven or anything else. If you're using anything which is Java, there's some way of integrating PMD into it. I mean, PMD has been around since 2002, so it predates pretty much every modern build tool that you're using, with the exception of maybe Ant. And I hope to God that none of you are using a version of Ant that old, because I've come across people who are. But anyway, very easy to use, and also very easy to kind of get the rule sets in there as well. There is a few things that you will need to do though. So remember that we talked about the fact that we use SMAP for JSP to Java basically matching, and also we're using for JSP compilation for PMD. We need to compile the JSPs as well. So we're going to need to actually turn those on. So SMAP dumped 2 and suppressed false. So we're going to actually have to turn the SMAP generation on, and we're also going to have to actually compile the JSP as well. So it's usually relatively straightforward to use, like for example, the Tomcat compiler, Jasper, to compile your JSP as part of the build process. Limitations, I mentioned this before. With Eclipse, we are limited to XPath rules only. It is possible to get Java rules working with Eclipse, but it's really, really fiddly. It's not something which is very easy for you to deploy out to a team of people. It's something you could do to your own build. It's really much easier if you look at doing this as part of an Ant or Maven build as opposed to on your desktop. So, last steps, and I think I've probably got about 5 minutes left for questions, have I? Okay. Go grab the code, go extend the code. If you want to feedback any rules for us to include with the normal one, fork it, give us a pull request. Definitely, we want to make sure that we kind of build on these things over time. We actually are releasing a new set of rules which are kind of more technology specific once we finish kind of QA on them, and it's gonna pick up some kind of SSO usage kind of things, a few bits and pieces to do with some scenarios that we've come across with these before. But ultimately, we want to extend this to make it at least something which is basically usable. So at the moment, it gives you, if you're not using static analysis, it gives you a capability you didn't have before with limitations. So you need to be aware of the fact it's only going to give you a few bits and pieces. But having said that, if you're not already using something like a Fortify or a Veracode or a Verity or etc. Already, then you're certainly going to end up with more information than you did before. I think currently at the moment we are looking at least extending it for PMD5. I think PMD5 came out about a little under a year ago, and it does extend the PMD to beyond Java. But at some point we'll integrate that to there. So I hope you all had some interesting fun talking about PMD. And any questions? Stunned silence.
Well, my question is not directly related to PMD, but I know one of our third-party providers uses a tool called Sonar, which I think in the background uses 5% PMD, to check for it. And there's also a plugin I think which is available in the market for OWASP compliance. So it basically shows a kind of matrix, shows that how the issues that we found, how it compares to the OWASP compliance asset. Any experience with that? Because we don't use Sonar ourselves. We use something else like Clockworks. But would be keen to know if you have any experience with the Sonar plugin for OWASP compliance.
I'd be very interested to hear what they're actually doing for OWASP compliance, since there actually isn't such a thing as OWASP compliance. and I only mention that because some of the flame wars on the OWASP readers lists about this kind of thing. I believe I have heard of that particular thing. Sonotype is a very useful thing. The find bugs and the PMD stuff immediately are going to be more quality focused. I don't know specifically about the OWASP one, but it's effectively that kind of situation which we're looking to kind of integrate some security checks into. Yeah. That's really what this is for. Equally, you could deploy that quite easily into a Sonar, which is effectively just a Maven building environment very easily. Yeah. That's exactly the kind of tool set that people have. That you can then, you can add a couple of things to the tools, add a couple of things to the class path, tweak a few of the scripts a little bit, and then bam, you're at least looking for basic examples of low-hanging fruit for a few of those OWASP top 10 things.
Yeah, no, I think this is very useful indeed because if you look at from an enterprise standpoint, there could be thousands of products going through development, and it makes sense if you have some kind of matrix to track these things because if you leave it to third-party providers, they may do it religiously, or they may not do depending on the time and other priorities that they have. So the plugin that I was talking about gives some kind of matrix to track things, but I think it's a good step in the right direction anyway. So.
Yeah. I'd be hesitant to actually think that you would be OWASP compliant. But I put it in air quotes. But certainly, and this is exactly what this project is like. Anything is better than nothing. Really. What this is you have a base level if you're not doing anything in this particular area. This is basically a step up from that. And you know, you may or may not need. I mean, that may be all you need. The next step is a big one. That's where you're talking about the commercial tool sets. And you know, there's an investment into that, it's getting it integrated and things like that. But really, it's kind of like this is like the first step, kind of down that road. You may then need to go the commercial route. If you're in a large enterprise, that's definitely the direction you should be looking to evaluate whether you want to or not. But you know, we want to make sure that at least everybody has some access to at least base level stuff. Any other questions? Cool. Well, thank you very much.